Hello students, welcome to grade 10 mathematics unit 5, which is solid geometry. So solid geometry is three-dimensional figure. So in solid geometry, we'll try to cover now these points. A frustum of a pyramid and cone. What is a frustum of a pyramid and cone? And how we can determine the surface area of frustum of a pyramid and cones. So here are a frustum of a pyramid. A frustum of a pyramid is part of a pyramid between a base and a vertex, formed when the original pyramid is cut off by a plane parallel to the base. That is what we call a frustum of a pyramid. So the frustum of a pyramid is part of a pyramid which is between the base and the cross-sectional area of a pyramid. So let's see using a figure. The frustum of a pyramid is obtained by cutting off a given pyramid by a plane which is parallel to the base. So the remaining part, which is between the base and the cross-sectional area, is a frustum of a pyramid. So if it is a frustum of a pyramid, what are the lateral surface areas of a frustum of a pyramid looks like? A frustum of a pyramid, the lateral surface looks like what? If we take one of the lateral surface of a frustum of a pyramid, this one is one lateral face of a frustum of a pyramid. So this is a plane figure, what we call a trapezium. So the lateral faces of a frustum of a pyramid are trapeziums. The lateral face of a frustum of a regular pyramid. What's a regular pyramid? A pyramid where the base is regular polygon and it is right pyramid. When the altitude passes through the center of the base, we call it is regular pyramid. If it is regular pyramid, the lateral faces are congruent isosceles trapezium. The two sides equal. Each lateral edges of a lateral face are congruent, and since a base is regular polygon, each side edges of a base are also congruent. So the lateral faces are isosceles trapezium. And what is the slant height of a frustum of a regular pyramid? The slant height of frustum of a regular pyramid is the altitude of any of its lateral face. The lateral height is the altitude of any of its lateral faces. Here we have a one lateral face for this frustum of a pyramid. So the altitude of the lateral face of this frustum of pyramid is what we call the slant height. So the slant height of a frustum of a pyramid is the height of one of the lateral faces. And the lateral surface area of a frustum of a pyramid is the sum of areas of all lateral faces. Here it's a frustum of a pyramid. There are four lateral faces. 1, 2, 3, then 4. So this frustum of a pyramid has four lateral faces. So the lateral surface area is equal to the sum of all these areas of a lateral faces. So we can represent in this form the lateral surface area and volume of a frustum of a pyramid for a frustum of a pyramid which is formed from a regular pyramid. So the lateral surface area equals to 1/2 L P plus B prime. So what are these L, P and P prime? P is a perimeter of base of a frustum of a pyramid. P prime is a perimeter of the cross-sectional area. What is the cross-sectional area? When a frustum of a pyramid is cut by a parallel plane to the base, so that section which is cut by a parallel plane to the base is what we call a cross-sectional area. Therefore, P is perimeter of the base. P prime is perimeter of cross-sectional plane. And the volume of a frustum of a pyramid is given by 1/2 times H, A plus A prime plus the square root of A times A prime, where A is area of a base, A prime is area of a cross section, H is altitude of a frustum of a pyramid, and also the total surface area of a frustum of a pyramid equals to the lateral surface area plus the area of two bases, the lower base and the cross-sectional base. So let's try to look examples here. It's like a revision. The lateral surface area is 1/2 L into P plus P prime. And what is the total surface area? The total surface area of a frustum of a pyramid is the lateral surface area plus A prime, that is the area of a cross section, or sometimes we call it upper base, then plus A, where A is area of base. Then the volume is 1/3 H into A plus A prime plus the square root of A times A prime. H is perpendicular distance between the two bases, perpendicular distance between the two bases. And this one is another very important point. Area of cross-sectional area over base area of frustum of a pyramid equals to K square over H square, where H is height of a pyramid before it's cut off, and K is the height of the removed part of frustum of a pyramid. Area of cross-sectional area to area of base equals to K square over H square, where K is height of the removed part of a frustum of a pyramid which is cut off, and H is the height of a pyramid, the original pyramid before a frustum of a pyramid is made. Example 1, the altitude of frustum of a regular square pyramid is 9 centimeter. The altitude, or what we call the height, H equals to 9 centimeter. What is the volume of a frustum? If side length of upper base 6 centimeter and the side of the length of a lower base is 10 centimeter. So what is A prime and A now? A prime is the area of a cross-sectional area or the area of upper base. But it says a frustum of a pyramid is regular square pyramid. If it is regular square pyramid, both the lower and upper base are squares. So the area A prime is 6 times 6, that is 36 centimeter square, and A is area of a base, that is 10 times 10, it is 100 centimeter square. Now what's volume of a frustum of a pyramid is given by H over 3, then into A, area of lower base, plus A prime, plus the square root of A times A prime. Now let's substitute. A volume V equals to 9 centimeter over 3, then into A is equal to 100 centimeter square plus 36 centimeter square, then plus the square root of 100 times 36 centimeter square. So the volume V equals to 9 over 3, which is 3 centimeter, then into, this is 136 centimeter square, then plus, what is the square root of 100 times 36? The square root of 100 is 10, the square root of 36 is 6, so it is 60 centimeter square. So what are the sum of these values now? It's 3 centimeter, then into 196 centimeter square. So this is equal to 588 centimeter cube. This is the volume of a frustum of a pyramid. Then another example 2, the area of a base of a pyramid is 90 centimeter square. The altitude of a pyramid is 12 centimeter. What is the area of a cross-sectional area? 4 centimeter from the base. Now, what's given? The given one, A, area of a base, that's 90 centimeter square. And the altitude of a pyramid, that's 12 centimeter. It's not altitude of a frustum of a pyramid. It's altitude of a pyramid. And what is the area of horizontal cross-sectional area? 4 centimeter from the base. So we have seen this relationship. Area of cross-section to area of base equals to k square over h square. What are these k and h? K is distance of a cross-section from the vertex of a pyramid, and h is the height of a pyramid. So here the height of a pyramid is given, which is 12. And what is the cross-sectional area from the base? It's 4 centimeter. So what is the distance of a cross-sectional area from the vertex? From the vertex, k equals to, that is 12 minus 4 centimeter, which is equal to 8 centimeter. Since it is 4 centimeter from the base, it must be 8 centimeter from the vertex of a pyramid. Now, area of cross-sectional area. Let's represent by x for simplicity. X over the area of a base is 90 centimeter square equals to k is now 8 centimeter over 12 centimeter the whole square. Now x over 90 centimeter square equals to, we can simplify before squaring, by 4 it is 2 over 3. 2 over 3 the whole square. This implies x over 90 centimeter square equals to 4 over 9. Now x equals to 90 centimeter square times 4 over 9, which is equal to 40 centimeter square. So the area of a cross-sectional area is 40 centimeter square. Then another idea is about a frustum of a cone. You may observe some like material which looks like this in your life, maybe in everyday activity you may observe such types of materials, which is called a frustum of a cone. Similar to a frustum of a pyramid, a frustum of a cone is part of a cone between a base and the vertex formed when the original cone is cut off by a plane parallel to the base. Here we have a lower, what we call lower base, then a cone. If we elongate, if a cone is intercepted by a plane which is parallel to the base, then the remaining part is what we call a frustum of a cone. So for this frustum of a cone, this one is what we call lower base, upper base, or we can say cross-sectional area. And the slant height, the side height of this frustum of a cone, and the altitude, or sometimes we call the height, perpendicular distance between the two bases is what we call the altitude. And the curved path or the curved surface is what we call a lateral face. Now how we can determine the lateral surface area and volume of right circular cone. Right circular cone. Right circular cone. What's a right circular cone? Base is necessarily a circle and altitude pass through the center of the circle or the center of the base. If so, the lateral surface area equals to 1/2 L times C plus C prime. It's similar with the frustum of a pyramid. The only difference is a term, circumference of base plus circumference of a cross-sectional area. 1/2 times L, 2 pi r plus 2 pi r prime, where r and r prime are radius of a base and radius of a cross-sectional area respectively. So if we factor out 2 pi, it can be cancelled by 2, L pi into r plus r prime. L is the slant height, r radius of a base, r prime the radius of a cross-sectional area. And the volume of a frustum of a cone, a frustum of a right circular cone, is 1 over 3h, a plus a prime plus the square root of a into a prime. That's 1 over 3 pi r square, because the area of a circle is pi r square plus pi r prime plus the square root of pi r square times pi r prime square. So if we simplify this, it will be reduced to this form. It's 1 over 3 times h times p into r square plus r prime square plus r times r prime, where r and r prime are radius of a base and h is altitude of a frustum of a pyramid. So these are formulas easier to find lateral surface area and volume of right circular frustum of a cone. Here we have example. A frustum of height 6 cm is formed from right circular cone, 9 cm base radius and 6 cm cross-sectional area. So what is the volume of frustum of a cone? Here the radius of a base is given 9 cm. Radius of a cross-sectional area is given, it is 6 cm. And the height of frustum of this cone is given at 6 cm too. So what is the volume? So the volume of a frustum of a cone is given by h times pi over 3, then into r square plus r prime square, then plus r times r prime. So v equals to h, height of the frustum, 6 cm times pi over 3, then into r square, that is 81 centimeter square plus r prime is 6, 36 centimeter square plus 9 times 6, which is 40. 9 times 6, that is 54 centimeter square. So the volume V equals to 2 pi centimeter, then into what the sum of these values? The sum of these values is equal to 171 centimeter square. So 2 pi centimeter times 171 centimeter square is 342 centimeter cube. That's the volume of this given frustum of a cone. This is exercise for you. A frustum whose lower and upper base are circular regions of radius 15 centimeter and 10 centimeter respectively is 20 centimeter deep. What is the volume? So use the formula and determine the volume. Already the answer is given. Check it. Exercise 2. A frustum of a pyramid has square base with side length 10 centimeter and a height of 20 centimeter. Calculate the surface area. So the surface area is this one. The surface area is equal to lateral surface area plus the area of a lower base and the cross-sectional area. So if we add that, you will obtain this. So what we have looked in our lesson, it's about a frustum of a pyramid, how to compute the lateral surface area, volume, and also what is a frustum of a pyramid and cone. So frustum of a pyramid and cone it's formed by, or it is part of a pyramid between a base and a vertex formed when the original pyramid is cut off a plane parallel to the base. Similarly, the cone is also, it's part of a cone which is between a base and a vertex formed by the original cone cut off by a plane parallel to the base. Lateral surface area for regular frustum of a pyramid. This also the lateral surface area and volume of a frustum of a cone for right circular frustum of a cone. So this all about the lesson. See you next time. Thank you.